No. Wait, I'm all get the answers. Oh wait, no, I have to.
Now, if you've already taken physics, you'll find this pretty easy. Hi. Yes, you will take the flash. Okay, the flash goes on your arm. Okay, that way it's not close to anything gross.
Okay.
All right, and you'll be back in a flash. Okay.
My family used to give us like a stuffed animal. It was really disgusting.
Yeah, no, I'm like, okay, it needs to, and then every once in a while I'll just like, throw bathe it in hand sanitizer.
I did it right after this.
Yeah.
Oh, I hate that. It's so hate it.
Okay, so we're going to start. Like I said, I tend to jump around a lot on page 46.
It's like
Okay, I'm going to draw lines because very often people don't know what we're talking about here. All right. Which one of these materials is the odd one out? What you're going to do is you are going to look at all the things in number 1, and you are going to tell your partner which one you think is the odd one out, which one does not match. When you and your partner are done all 4, give me a little wave so I know you're done. Okay, I'm going to write the letter E. E is going to stand for, can you guess what? Element. And what do you think the other letter is I'm going to put up? C is for compound. Okay, and we're going to see if you guys can remember any of the formulas. All right, so this is just kind of like a little review of stuff, from grade 9 and 10 and just a refresher. Because for some of you, maybe you took Science 10 like way back in first semester of grade 10 and it's been a long time. That could very, very well be. So let's just wake our brains up again. Does anyone know the symbol for copper? Cu. Now, is that a capital U or a lowercase u? Lowercase. The first letter always of an element always has to be a capital, and if there is a second letter, it must be a lowercase. Gold, AU. AU, that's my gold watch. Come back with that. Okay. Salt, NaCl. So we have capital N, lowercase a, and then C, capital C, lowercase L. That is sodium chloride. And how about sulfur? Sulfur is S, and you'll notice that it is spelled with a PH. However, we can also spell it with an F. Okay, you'll see both ways. Sulfur with an F is actually the correct way, but all of our resources in BC were made with the PH. And so I tried to make my resources match with the pH, and it's too much work for me to go back and change it now. So just be okay with either of them, okay? So you can see that we have one capital letter, one capital letter, one capital letter, and two capital letters. That means that copper is an element, gold is an element, sulfur is an element, and sodium chloride is a compound. In number 2, which one is the odd one out? Is it rust, silver, water, or wood?
Silver.
Silver, because silver, Ag, is an element. Does anyone know what rust is made of?
H2O.
Oxygen and what else? It's a metal. Do you guys know what element rusts and makes all that red, crusty iron? Fe, yeah, so it's Fe2O3. I want you to notice, where do those little numbers go? Do they go at the top or do they go at the bottom? They go at the bottom. Subscripts. Sub meaning? Lower, below. So if you go in a submarine, you are going under the marine, which is like the ocean, okay? If something is subdermal, it goes under your skin, okay? Thank you very much. And by the way, this is our bathroom / go get water pass. This is the flash, okay? And it goes on your arm so that it's not near anything gross, okay? Which is hopefully a very good thing. And hopefully it will remind you that you need to be back in a flash. Or if you've gone to the washroom, back in a flush.
Oh my God.
Okay, so he's just here. If you need to go to the washroom or whatever, just come up, ask me, and you grab the flash and off you go. Okay, he's right there. All right, do we know the formula for water?
H2O.
H2O. And again, how many capital letters in water? Capital H,
Capital H, capital
capital O. So we have 2 capital letters, 1, 2. So that is a compound. Fe2O, how many capital letters? 2 capital letters. So that is a compound. And wood, there's no way to know exactly what wood is. It's made of many, many, many different things, but it is mostly made of carbon and hydrogen and oxygen. So I've written CXHYOZ because we don't know what those numbers are. They could be anything, varied from time to time. Yeah. Well,
depending on
what part of the wood, and like some of it's made of sugars and some of it would actually maybe even have nitrogen in it or sulfur, but that's the basic formula.
But you can tell like maple wood as opposed to oak wood as opposed to orange wood.
Yeah, there would be other things in there, like other compounds, even sometimes other metals, like that are sort of just absorbed in there. Yeah. Okay. Who is the odd one out in group 3? Plastic. Okay, because helium, how many capital letters? 1, therefore it is element. Oxygen. Now, do you guys know something about oxygen that makes it a little special?
Okay,
it is O2. Okay, it is what we call a diatomic. Di meaning 2, diatomic 2 atoms. Okay? Plastic is made of C, we don't know how much, and H, we don't know how much, and O, we don't know how much. And guess what? Wood and other organic matter, like animals and other plants, they all die off at some point, and then they get buried under layers of earth and things like this. And eventually they get compressed and compressed and compressed, and they degrade and they react and they become oil. And oil is used to make plastic. It's one of the key ingredients in plastic. They synthesize it from oil. Not all the time. There's other things that can make plastic as well, but that's one of the ways. Yes?
So paper would also then have
carbons and hydrogens and oxygens. All living matter is mostly carbon, hydrogen, and oxygen with a little bit of nitrogen, phosphorus, and sulfur thrown in there for good measure. And of course, we have iron in our blood, okay, plus calcium in our bones and whatever, but all of our sort of tissues and things like that are mostly made of CHO, okay? And then, of course, potassium. Do you guys remember the symbol for potassium? K. It's one of those weird ones, right? I forget why. I think it's kalium in Latin. Okay, so anytime you have a weird letter, it's usually Latin, although it can sometimes be other things. Like, I don't know, tungsten is W, which stands for Wolfram, which I think is from German. I think. I don't know. Okay, how about our last row here? Sand, because sand is a compound. And if you don't know what that compound is, it is mostly made up of silicon, SiO2, silicon dioxide. Okay? It forms networks. Silicon is a metalloid, but metalloids often bond as though they were nonmetals. Do you guys remember how a nonmetal bonds to a nonmetal? They bond with the type of bond that starts with a C. Ooh, heard it? Covalent, okay? And when you have silicon dioxide, every single one of these bonds is a covalent bond, and covalent bonds are really strong. So that's why sand is very, very hard, is that every single one of those bonds in between the silicons and oxygens is a covalent bond, and that's very, very strong. So it makes it really hard and very strong, okay? This actually is not silicon dioxide. This is all carbon atoms. And if this is all carbon atoms, this is actually diamond, okay? Which is why diamonds are so hard and strong, because they're all made with covalent bonds.
So glass is made by...
Glass is a type of silicon dioxide. It's less organized than in sand. It's like what they call an amorphous solid, so it doesn't have a pretty regular crystal structure like this. Things are sort of like unbonded here and unbonded there and all over the place. Yeah. Okay, carbon. What's the symbol for carbon? That one's super hard. C, that is an element. Bromine is Br. Do we need to know anything about bromine?
Also exists as a
Bromine is a diatomic, and magnesium is Mg. Watch out, there is another element called manganese, and it's different, and it is Mn. Okay, so just watch out for that. All right? There are many different materials in this world, but only around 100 elements. I think we're up to 120 now. These elements can be combined in many different ways to form thousands of different compounds. An element is a substance made of only one type of atom. So you can see that copper, they all look the same. Unfortunately, you guys, your little copy doesn't have the colors, but copper is made only of Cu. So you've got Cu, 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 right? We've got carbon, which is made only of carbon atoms, and helium, which is a, what state of matter is helium? It is a gas. Do you guys know the symbol for showing something as a gas? It's a G, and we put it, it's a lowercase g, and we put it in brackets. Now, copper is not a gas, it is a solid. And you guys know the symbol for solid? S, again in brackets. Okay, carbon is also a solid. S. Can any of you point to some carbon right now? Some actual carbon. Like carbon as an element. Elemental carbon. Carbon on its own.
That's what
You have carbon in you, but it's a part of compounds. Almost all of you are right now sitting within like inches of carbon. Pencil. Yeah. Your pencil lead is actually carbon. Okay. So we have diamond is carbon. Okay. And that is this kind of carbon. Okay. It's this lovely, like sort of pyramid-like structure.
We also have graphite.
Which is what it is in your pencil. Now, my pen does weird things. So if you see lines like that on top of the H, it's not because I'm drawing that line. My pen just puts lines places sometimes. So please just ignore them. I will try to correct them, but I don't know. It's just a quirk of this computer, okay? Now, this is a carbon atom. This is a carbon atom. These are non-metals. What kind of bond is that in between the non-metals? Starts with a C. Everybody, what kind of bond is that in between non-metals? Covalent. Is it strong or is it weak? Strong. So, what shapes do we have here? We have hexagons, yes? And how many sheets of hexagons do we have? We have 3 sheets of hexagons. Now, these bonds are covalent bonds. They are very strong, or are they weak? Strong. Unfortunately, these ones, because this is a model, we can't make them out of anything else. Really, steel works really nicely. These are not covalent bonds. These are what we call intermolecular forces. They are the forces between molecules. Inter meaning between, molecules, intermolecular, in between molecules. Don't worry, we'll come back to this later. Okay, but I like to introduce ideas to you so that you've heard it many, many times. Okay, spaced repetition, right? So we have Intermolecular forces. Intermolecular forces are strong or weak? They're weak. I don't know why I'm asking you like you already know this, because you don't. Or maybe you do, I don't know. They're weak. So when you get your pencil and you put it down on your piece of paper, if my hand is the piece of paper, there are actually intermolecular forces forming between that sheet of graphite and the paper. So there's stickiness between the paper and the graphite layer. And so it will actually stick to your hand, and these intermolecular forces between that layer and the next layer will break. And so you'll actually end up with this layer coming off on your paper, and that's how a pencil works.
Oh, wow.
Right? So you can imagine each layer shears off as it goes, and that's how your pencil works. What about ink? Ink is just going to be based on various chemicals. It'll be probably organic based. Yeah. Different process entirely. Yes, because they're liquids, so they'll be a dye dissolved in some sort of solvent. Yeah. Yeah. Well, interesting, but more complicated. Like I can't say ink is one thing.
Yeah.
Right? There's all kinds of different inks, whereas graphite is graphite. Yeah. Helium is made of only helium atoms. How can you tell the difference between the solid and the gas? Stuck together. Yeah. Okay, so the gas floats freely. It fills its container. So it doesn't like sink to the bottom of the balloon, okay? So if I put some liquid into this big gigantic cup here, actually I'll put some liquid into this, which is just here because it needs washing, but good enough time to rinse it anyway. So if I put some liquid in here, does it fill its container or does it sink to the bottom? It sinks to the bottom, yes? And if I put a solid in there, along with it, there we go, a little eraser. It sinks to the bottom. But there's something a little bit different about the liquid and the solid. The solid, who takes the shape of the container? The liquid. The solid does not take the shape of its container. It maintains its own shape. Okay? So a solid has a fixed shape.
Aqueous.
We'll get to aqueous. Aqueous is dissolved in water. Okay, so this eraser is not dissolved in water at all. But if I had salt and I stirred it around, it would look just like water. Okay, and that is a solution. And we're going to be dealing with solutions in this unit. And it's a type of homogeneous mixture. Have you guys heard that word before? Just raise your hand if you've heard the word homogeneous before. A lot of you. Okay, if you haven't, that's okay. We will learn it. All right. So a solid has a fixed shape. And we'll just put that a liquid, which can, what is the abbreviation for liquid? L. A liquid takes the shape of its container. And the particles are tightly packed. Whereas the solid has a fixed shape, but the particles are also tightly packed. Is good? Okay. Molecules of elements. Atoms of some elements join together. What do we call it when atoms join together? What do we call that force holding them together? That's a bond. Okay, so when they join together, when they bond, some of them make molecules. And when we say some elements, what we're really referring to here is if they're making molecules, are they metals, are they non-metals, or are they a combination of both? Molecules are actually exclusively non-metals. Non-metals.
Oh, thanks.
That's okay. This can be like, there's a lot of words, right, for you guys to know. So you might want to start making yourself a vocabulary list. You could start making like little flashcards. You can be like, that would be one way of making a strong primary memory, right? I wouldn't necessarily assign this as homework, but if you're like, I don't have as much to do tonight, I might go back through 1.3c and go through and say, I need to make sure I know the word bond. I need to make sure I know the word molecule. Yeah.
Compounds, is it used? It's not used like for everything.
No, compounds are exclusively if you have two or more elements joined together by bonds.
By bonds. But
Yeah.
It can be used to designate molecules as well. But
No, not all molecules are compounds and not all compounds are molecules. We'll get to that later, okay? Don't stress about it right now, okay? Compounds are two or more elements bonded. Whoops, I cannot spell. Bonded with a T. What is wrong with me? Bonded together. How is that different from a molecule? Because molecules have to be nonmetals. And also it says atoms, which does not mean they have to be different elements. They could be the same element. You can have the same element making a molecule, which is not a compound. Okay? So one of the other elements that exists like that is hydrogen. Each hydrogen atom joins up with one other hydrogen atom to form a hydrogen molecule. Okay, so here's an H. Here's an H with a what kind of bond? Tell your partner what kind of bond? Covalent bond. Okay, and if you're like, why on earth does that one have to have two little guys? It's because, what would I do if I wanted to draw a Bohr model for hydrogen? What goes in the center of a Bohr model for hydrogen? We have our little proton, yes? And it's just atomic number 1, so how many protons does it have? 1. And its mass is also 1. So how many neutrons does it have? 0. Because protons weigh 1, neutrons weigh 1. Okay, so protons weigh 1, neutrons weigh 1. Don't worry, this is unit 2, this is unit 3. So if you're like not getting this right now, don't worry. Like I said, little previews. Okay, previews and reviews. So protons have a mass of 1. And so if the entire atom weighs 1, then you cannot have any neutrons, because if you had a proton and a neutron, it would weigh 2. Okay? So it's got a mass of 1, so it's just got 1 proton. Electrons are too small to worry about. Their mass does not. It's like having a little flea on your shoulder. When you step on the scale, it's not going to make a difference, right? How many electrons does hydrogen have? 1, because the number of protons and the electrons have to be the Same, because the charge of an atom is always neutral. You must have the same number of positives and negatives. So we've got a positive in the middle, we've got a negative around the outside. That's our first shell. Do you remember the term shell? Okay, that's our first shell. How many electrons complete the first shell? 2 electrons. So the first shell is full with 2 electrons. Do shells like to be partially full, or do they like to be completely full? They like to be completely full. So if I've got a hydrogen and I have another little hydrogen here, and little hydrogen is like, oh, I wish I had a full shell, but I don't. I'm so sad. What can I do? How can hydrogen become happy?
Bonding.
It can bond. So what I would like you to do is I would like each of you with your partner, or you can, like, you know, if we've got like a 3 and a 3, maybe you two guys can go together or something like that. Okay, do your best. You're each going to hold on to a pencil. That's going to be your electron. Okay? So everybody grab your electron. Each grab an electron. Everybody grab their electron. Okay, and I need a volunteer to come up here and be my partner. Are you coming? Come on up. Yeah, come on up. You got an odd number back there anyway. Come on, Brad. Come on. Yeah, yeah. Come. Thank you. Okay. So what you're going to do, I'm a hydrogen atom, and I have my electron. Yes? You're just put that down for a second. You can keep your pencil back, okay? Okay, that is your electron. Okay, this is my electron, this is Dylan's electron. Okay? And I'm so sad because this hand needs an electron to be full. Yes? And that hand is sad because it needs an electron to be full. So, how can we help each other out? Okay, hold on tight. Now, remember, what charge are electrons?
Negative.
They're negative. What charge are protons?
Positive.
Okay, so you're a proton and I'm a proton, and these are electrons. So we pull on those electrons. So what you're going to feel, you're going to feel a pulling force. That is a covalent bond. Okay? So what you're going to do, you're going to form a covalent bond with your partner. And if you don't have a partner, form a covalent bond and pull. Both of you pull. Feel that covalent bond. Very good. Very nice. Okay. So they share electrons, and the sharing of electrons is a covalent bond. So what you'll end up with is 2 electrons being shared by the protons. And we are almost out of time. So I think, yeah, we're getting close. Today we are done at 41. Yeah. So what I'm going to do is I'm going to give you your homework, which is, first of all, 1.3a. You are going to watch the video. And fill in the blanks.
Be online. You can find it in the. You can also put that link.
So you can, how are you going to access this video? You can either go go to that QR code and that will take you to the video, or you can go to Teams. Where is Teams? Teams, there it is. And you can go to our general channel and you can go to Files and you can say, I want my general channel. Files, Unit 1, 1.3a. And then you can click on that thing. Okay? Now, this is un pequeño amount of homework. I'd like to give you more. I would like you also to do 1.2a. Watch the video and fill it in. Now, if you're like, my God, Ms. Spence gives a lot of homework, the one video is like only 5 minutes. Yeah? Oh, solutions video is 1 minute and 52 seconds. And 1.2a, which is on page 35. Do you guys know how to use your table of contents? Yes, you can find 1.2a. 35. There is a 10-minute video and a 10-minute video. So you have about 25 minutes worth of homework, which I think is reasonable. Okay? 25 minutes worth of videos. Not too bad. There's a 10 and a 10 and a 2.
Oh, okay.
So even if you slow things down, you can probably get it done in 25 minutes or so. Yeah. I will participate. Oh, wow. Otherwise, it's going to be too old.
I like chemistry. I don't know if I'm good at it, but I like it. So.
Well, in your participation, if you participate, there will be a video. Yeah. Yeah.